Okay, so let's discuss the problem that we okay, so let's discuss the quiz that you had last April 28th. So we have here um, number one, no, the first one, which is a series circuit between an independent voltage source and a dependent voltage source, and we have two resistors. Now, since this is series, okay, finding the power, okay, uh, is easy. So we have here the loop is going that way, so we have I1 going also clockwise. Okay, we call the current now I1. Now here, since we in the source, we always come from the lower potential to the higher potential. Then from the in at the resistors, we have from the higher potential to the lower potential. So we have, okay, 45 volts. Here we have minus VO, and then here we come out at the positive side, so plus 3 VO, and then we have minus 5 I1. Minus because the direction of the current and the loop is just the same. Now this is 45 plus, this becomes 2 VO, okay, this becomes plus 2 VO minus 5 I1 is equal to 0. Okay, now our VO here is equal to, since this is voltage, this is just the product of the current I1 times the resistor 10, which is 10 I1. So I can now replace VO with 10 I1 minus 5 I1 is equal to 0. So 2 times 10, that's 20, minus 5, that's 15 I1. I'll transfer this one to the other side, so that's negative 45. Negative 45 divided by 15, that's negative 3 amperes. Okay, now to find the power, okay, which is what we're looking for in this problem, we have I squared R. The current all throughout the circuit is the same. That's negative 3 squared times the resistance, which is at 5 ohms. We have 5. Power now is equal to 45 watts. So notice that the current is negative. That means we assumed the wrong direction for the current, but it's okay since it is reflected in the negative sign. Okay, for the next problem, so we have here the circuit finding the resistance at terminal AB. So we have here the okay, so we have here a problem. Okay, so we have here finding the resistance at terminal AB. So we have here a problem. Now, since we cannot solve this through uh, basic series and parallel combination, so we might as well use delta to y transformation. Okay, so for me, I will choose these three parts. Okay, this one, this one, this one. I'll change this into a delta, so it will look like this one. The other is here. Okay, okay. Now I will call this one as A, call this as B, call this as C. So what will happen next is, okay, to find A, this one, to find A, you need to, so A, since this is from y to delta, so we need to look for the opposite of A. The opposite of A is here, the 30. So we have here 30 is the denominator. Now the numerator will be Okay, let's just multiply each possible pairs. So we have 24 times 20 plus 20 times 30 plus 30 times 24. Now A here is equal to, give you a calculator, so you have 24 times 20. Okay, sorry. So we have 24 times 20 plus 20 times 30 plus 30 times 24 is equal to 30. So the result is 60 ohms. So we have here A is 60 ohms. Now for letter B, so we have the opposite of B is 20. This one, 20 ohms. So let's just put 20 ohms there. Then we have here 24 times 20 plus 20 times 30. Okay, plus 30 times 24. Okay, so all we need to do is this one we may edit this one, then replace the denominator with 20. So we have here the 90 ohms for B. How about for C? So for C is 24 times 20 plus 20 times 30 plus 30 times 24 divided by the opposite for C. Okay, here we see the opposite is this one. Okay, so that's 24 ohms. Here 75 ohms. Okay, now we have known this values already, so we have here, if we redraw this one, so it will look like this. Okay, and this one is another resistance, and we have here resistance, another resistance. So this is A, this is B. Okay, so that's how it will look now. Now to continue, okay, to continue this one, so all we need to do is combine these two because these are parallel now, this and this one. So this becomes parallel, so that's A and 10. Okay, so to answer this one, so we have green. So this is A parallel 10, this one is C parallel 50. So to move, so we have, if I have to answer this one, A parallel 10 is just like, okay, A is, okay, we have 60 ohms. A is 60 ohms. Then we have, okay, 10 ohms for the other resistor. Okay, so inverse everything, so it should give us, okay, so we have 10 to the power of negative 1, so this should be 60 over 7. Okay, now this is C parallel 50, and this one is 75. C parallel 50 is equal to, C is equal to 75. So this is 75 inverse plus 50 inverse, then inverse everything. So it should look like this one. 75 inverse plus 50 inverse carrier 30. So this one. Now if we are going to change the figure again, okay, this one, based on this one, it will look like this. Okay, so it will look like this one. Okay, this is A, this is B. Now if we're going to recall, this is 13, and now, okay, B is equal to 90. So this is 13, this one is 90, this one is 60 over 7 from here, this one is 30. Now since this is very easy to look at, okay, when you actually think of solving it, I'll just say this one, these two are, this series combination is in parallel with 90, then again it is in series with 13. So if you want to find out RAB, so these two are in series 13 plus, okay, the parallel combination of 90 and 60 over 7 plus 30. Okay, you have 13 plus 90 parallel, 60 over 7 plus 30, so that's, you have your calculator. Okay, you have here 270 over 7. Okay, so another one, so RAB, okay, 13 plus, this is 90 inverse plus 270 over 7 inverse, then inverse everything. So let's see what's the answer now. So 13 plus, okay, 90 inverse plus, okay, let's put a parenthesis, 270 over 7, okay, inverse, then let's inverse everything. This should give us 40 ohms. So the answer is 40 ohms. So let's solve the next problem, which is to obtain the voltage at node 1. So this point, so I call it V1, I call this V2, then this is now our reference point where the voltage is 0. Now if we are going to have a KCL at node 1, so here let's assume the current I1 is going there. Of course this is going down, I2, okay, this is I1, I2, and this one is I3. Okay, at node 1, so we have what's coming is 1 amperes, then I1 and I2 are leaving. Okay, I1 and I2 now are leaving. So I1 plus I2 is equal to 1. Okay, now we have voltage, okay, to find, okay, so this one, for I1, okay, I1 is that the tail is V1, the tip is V2, so this is V1 minus V2 over the resistance in between, which is 6, plus the I2 is, okay, the tail is V1, then 0, so this becomes V1 minus 0 over resistance in between is 2. Okay, so this is 1. So we have 1 6. Okay, so this one is 1/2, so 1 6 plus 1/2, that's both for V1. This one is minus 1 over 6 V2 which is equal to 1. Now combining this 2, so we have this becomes 4 over 6, or let's say 2/3. Okay, now 2/3 v1 minus 1/6 v2. Now to create, this is our equation number 1. Doesn't matter if it has fractions. Okay, it's not yet a final answer, so it's okay. Now here we have, going through this one, what's coming in is I1 at node 2. So what's coming in is I1. Going out are I3, and okay, so I'll just erase this first. So okay, so I1 going in, I3 going out, 4 amperes going out. Now you have your I1 is from V1 minus V2 over, in resistance in between is 6, minus I3. I3 is V2, okay, minus 0, okay, divided by 7 minus 4 is equal to 0. Okay, so proceeding with the problem. Okay, so okay, we have here, so V1 is 1/6 V1. How about this one? This is negative 1/6. Okay, this is plus negative 1/6 minus 1 over 7. This is all for V2. Then this one is equals, transfer to the other side, so 4. 1/6 V1, okay, minus 1/6 minus 1/7, so that's 13 over 42 V2 is equal to 4. Now I don't want you to use any more elimination and substitution. We'll just use calculator directly. So you have your mode, okay, 5, equation 1. Okay, this is 2/3 negative 1/6, so you have 2/3 negative 1/6, then 1. Okay, proceeding to the other one, so we have 1/6, okay, negative 13 over 42, yan, so 4. So the answer is negative 2 for V1, and then V2 is negative 14. V2 is negative 14 volts. So the answer is this one. Mesh is going right there, so we have, it comes out from at the 12 volts, so positive. Okay, since the same current and direction, so we have minus 2 I1, and here 12 ohms is influenced by both I1 and I2, so that's why we have 12 I1 minus I2. Okay, another is this one for the same current I1. Okay, so that's why we have 4 I1 is equal to 0. So we have 12 negative 2 minus 12, so that's negative 14 minus 4, so we have negative 18 I1. Negative 12 times negative I2, that's plus 12 I2 is equal to 0. So finally we have 18 I1 minus 12 I2 is equal to 12. So this is equation number 1. Now you may choose between A, B, C, D, E, F mesh, or maybe B, C, A, E. Now for me, I will choose the big loop. Okay, I will choose I will choose mesh A, B, C, D, E, F. Okay, so I'll choose this one. So here coming out is positive 12. Here we have minus 2 I1. Here we have I2. Okay, the same direction. So we have 2. No, not 2, but 9. Supposedly 9. Okay, I2. This one comes out at negative 8. Okay, this one is minus 3 I2, this one. So now we have minus 4 I1 is equal to 0. So finally we have 12. Oops, sorry, we have forgotten something. So supposedly 9, then 9 I2, then 8. Okay, so I think it's already okay now. So 12 minus 8, so this is 4. Negative 2 minus 4, so that's negative 6 I1. This is 9 minus negative 3, that's negative 12 I2 is equal to 0. Okay, so to proceed, so we have 6 I1 plus 12 I2 is equal to 4. This is equation number 2. Now we will not be dealing with elimination and substitution anymore. Let's just use our calculator directly to find I1 and I2. So I'll have here calculator. Okay, press mode, then 5. Okay, two equations, two unknowns. We have 18, negative 12, 12. So we have 18, negative 12, then 12. So another one, so we have 6, 12, 4. 6, 12, 4. So we have 2/3 and 0. The current is 2/3 amperes. I2 is 0 amperes. So the answer is this one. I2 is 0 amperes.